Hi friends, in this video we are going to talk about the weaving ratio at a rotary intersection. A rotary intersection can be also called as roundabout simply, right? Weaving ratio, the term that we are using in the design of rotaries, will be mainly coming at the capacity calculation of a roundabout. But before directly going into that term weaving ratio, let me just talk about what is actually happening in this roundabout or rotary. Now see, whenever a vehicle is entering into the roundabout, let me just take the example of this particular car. I hope you're able to see that. So this car, whenever it is entering into the, what I can say that rotary road, either it can take this particular exit, or again it may be turning and taking this particular exit, or again it will be moving in the clockwise direction and taking this particular exit. Now, in this particular roundabout, it is having three different options for exit, right? Because it's a four-legged intersection. So in the questions, either they can give you, see, four-legged intersection or three-legged intersection or five-legged intersection, whatever be the number of roads which are meeting at that particular roundabout, the procedure in which we calculate the term weaving ratio remains the same. So you need to understand what is actually happening there. So in this particular video, we are not going to discuss the calculation of weaving ratio in the conventional way. There is an equation to calculate that by checking how the vehicles are coming and where it is going, in which leg it is taking the exit. It's a conventional way, and also it is a little bit complicated. I've seen students are making mistake repeatedly, even after explaining it like anything. So in this video, what I'm trying to do, I'll be telling you a trick or a very simple way of calculating weaving ratio, whatever be the number of legs they are giving. We'll be doing two different sample questions as well. Okay. So as I told you before, the term weaving ratio we'll be seeing in the capacity calculation or in the capacity equation, right? I hope you have already gone through this equation, one of the important equation in the what I can say geometry design of or the design of rotary. In case if you have confusion in this capacity calculations and the terms in this equation, this W, E, L and all, please let me know in the comment box. We can do a separate video regarding the capacity calculations, some numerical questions. In case if some of the terms are not available in the question, what to do. So all these things we can discuss separately. Now, if I'm going behind that also, this video is going to be lengthy. So I just want to stick on to this particular topic, weaving ratio only. So this P, which you can see here, P by 3, this P is nothing but our weaving ratio. So how to calculate that? In general, I can say that is nothing but weaving traffic divided by total traffic. So this is how we generally used to calculate it. One second. Yeah. So this is how generally we used to calculate it. So what we used to do practically, see here now I'm having 4 legs, right? So in between 2 legs, first of all, I'll be calculating one particular weaving ratio. Let me just call it as P1. Between the other 2 legs, means from this and this, I'm taking this particular location between 2 different adjacent roads. Okay, that's what we mean by leg. So here also I'm going to calculate another weaving ratio. Let me call it as P2. Now between these 2 different roads, I'm just taking this location. Again, I'm going to calculate the same ratio, weaving ratio that I'm just naming as P3. Different values I may be getting, okay? One more ratio I can calculate here, which is P4, which means between 2 adjacent legs or between 2 adjacent road, we can calculate this weaving ratio. So according to this particular image, I can calculate 4 different weaving ratio. If it was a 5-legged intersection, then we can calculate 5 different weaving ratios. Now, which value we are going to substitute in this equation? Here only we are having P by 3, right? Which P we are going to substitute here? It is not the average of all these things. It is not P1 plus P2 plus P3 plus P4 whole divided by 4. No, it's not like that. what we need to do, whichever is maximum, okay, whichever is maximum out of this P1, P2, P3 and P4, that one particular value we need to pick and substitute in this equation. So that's what we generally used to do. Clear? Now to calculate this weaving ratio P, we are having an equation. What is that equation? This is that equation. This is what I told you, the conventional way. But we are not going to, follow this particular equation to calculate. Definitely it's going to give you a lot of confusion. In this, that B plus C, the term in the numerator, that is nothing but our weaving traffic, and A, B, C, D, the summation of A, B, C, D, that is nothing but our total traffic. Okay, so that's what we have written here, weaving traffic by total traffic. So in this equation, either what they can do, in the question directly they can give you how many number of vehicles are in the weaving operation, or what is the weaving traffic and what is the total traffic. Directly they can give this. If they are giving directly, then there is no point of calculating anything. Directly we can take the ratio and substitute there. That's it. What we are going to discuss in this video is, in case if they are giving the number of vehicles instead of directly giving you the weaving traffic and total traffic, they are just giving, okay, from this particular leg or road 1, some vehicles are moving in the, to this road 2, some vehicles are moving towards road 3, some vehicles are moving towards road 4, like that, a set of data they'll be giving sometimes. So if they are giving data like that, how to calculate that weaving ratio, that's what we are going to discuss. So I'll discuss that concept with the help of a numerical question, which is actually a previous engineering service exam question. So let's try this, okay? So once we are doing this, whatever question they are going to ask, we can easily solve it. One more question we are going to solve. Okay, this is the first question, clear? Now see, whenever they are giving the data, either they can give in the form of a table like this, or they can give you a picture, what I can say, a graphical representation. Okay, in a, what I can say, somewhat a diagram of a roundabout they may be giving, and they will be marking all the directions and values. I'll be telling you how it is. Look at this. What they have mentioned, V12 is 150, V13 is 450, V14 is 412. Similarly, V21 is 310, and so on. Now, what is this V? I haven't written the entire question here. I have just written the data. V stands for the volume or number of vehicles. That's it. Okay. And this 1, 2, 3, 4 indicates the name of the leg or name of that road. Clear, no? Which means from 150 vehicles are coming and going into leg 2. Right. Simply if I'm drawing that intersection here, suppose this is the center island, and the road is coming from this direction, and see, some vehicles will be going into, okay, this is leg 2, for example, and here is leg 1, and here is leg 3. I'm just explaining this question. I mean, explaining the concept with the help of this question, okay? So this is leg 4. Okay, so some vehicles are coming from leg 1 and it's going into leg 2. How many vehicles? 150 vehicles. Clear? Now, some vehicles are going to leg 3, right? How many? 450. So how they are going to draw it? They'll simply draw it like this. Enough. Understood? So from this, we can easily understand that, okay, 450 vehicles are going into leg 3. Clear? Now, 1 to 4 is 412. How they can show that? Like this. 412. See, it doesn't mean that the vehicles coming from 1 is going to leg 4 by taking a right turn. No, it's not like that. In a roundabout, the vehicles cannot take right turn directly like that. No. So what they will do? They will enter into the roundabout. They will take the clockwise movement. And whenever they are reaching here, then they will be taking the exit. So this is what is happening in a roundabout, right? We know that. But instead of just drawing like that round clockwise, what I can say, see, like this, instead of drawing like this, they'll simply represent it just by putting an arrow like this towards the right side. That's it. Enough. Clear? Similarly, See the second set of data, V21 means from 2, there are many vehicles coming to leg 3, leg 4 as well as leg 1. That's what mentioned there. So let me just draw that leg 2 to 3 first. How much it is? 200, right? Hope you are following. Now from leg 2 to 4, how much? 1090. Then some vehicles will be, taking this direction like this, then it will be coming to this direction. I'm not going to show that entire path. I'll be just drawing like this. Hope you're understanding that. Right or not? Yes. So how much it is? 2 to 1. It is 310. Understanding, guys? So try to draw the remaining things also. Everywhere I can just draw like this. You just mark that. Now you can easily do it yourself, right? 3 to 2, it is 570. Then 3 to 1, it is 1520. 3 to 4, it is 240. Now you can just write yourself. No need to wait for me to write. Just write yourself without looking at the screen. And just check whether you have written the correct values only. Hope you have done it, right? So this is what I told you. Either they can give you the data like this in this first way, I mean, by giving in the form of a table, or in this second way, simply a graphical representation. So let them give the data in whichever way they want to give. We can easily solve it. Okay, now let's see. In this question, what actually you need to calculate? You can just mention that question also. I need to calculate the weaving ratio between simply 2 and 3. That's it. So between 2 and 3, I need to calculate what is the weaving ratio. So practically what I need to do, between 1 and 2, I need to calculate. See here, I can calculate one ratio, P 1 to 2. Here also I can calculate another ratio, P between 2 and 3. Similarly, here also I can calculate P between 3 and 4. Similarly, here also P between 4 and 1. Understanding? So practically we need to calculate all these 4, whichever is maximum. That one particular value we need to substitute in our capacity equation. But in the examination, they cannot ask you that much lengthy question, right? Maybe in the conventional paper of engineering service exam or other exams, okay, where we have the conventional paper, SSC second paper, like that. There they can ask it for somewhat 10 mark, 15 mark, 20 mark, like that. Then, okay, it's possible to ask all the 4 and pick the maximum. In case if they want to ask a short question, then any of these weaving ratio, they will particularly mention which weaving ratio we need to calculate. Only that we need to calculate. Okay, so here I'm just making the question. We need to calculate the weaving ratio between leg 2 and leg 3. So how we are going to calculate? Let's see, in a very simple manner, that will be equal to, so 2 things we need to calculate, no? What all things? The weaving traffic as well as total traffic. So let me just tell you the total traffic first. Okay, that is somewhat easier. The total traffic means what? Don't think that it is the sum of all the values given. No. What is the meaning of that total traffic? It means the number of vehicles which are using that particular location, which we are considering as of now. Which means, what is that location under our consideration right now? Between leg 2 and 3, right? So between leg 2 and 3 means this portion, right? This portion. So whichever vehicles are using that particular location, that's what we need to consider now. That is what is the meaning of total traffic. We are only writing simply as total traffic, but actually it is what? The total traffic or the total number of vehicles which are using that particular section under consideration. Which means what? If I'm just considering leg 1, which all vehicles will be using that location? Whether these 150 vehicles will be using it? Absolutely no, right? Because they will be coming into the intersection like this. They'll be turning like this. Then they'll be taking the exit. So this is what is going to happen. They are not going to use that section, colored section, right? But what about this 450 vehicles? Yes. They'll be coming like this. They'll be turning like this. Yes, they are going to use this location, then they will be taking the turn. Understanding? So those 450 vehicles will be definitely using it. Now, similarly, what are the other number of vehicles? What about this 412? Whether 412 will be using? See, they are going to, once again, let me just rub this. Otherwise, later you are going to get confusion. Okay. What about this 412? Obviously, they are going to use this. Then only they can take this turn. Right or not? Obviously. So now you are getting the point, no? So similarly, this 200, whether 200 will be using it? Obviously, 200 also will be using it, no? Without using it, how can it go to leg 3? 1090, obviously that also will be using 310. Of course, yes. Don't think that it is going like this. You know, it's a roundabout. So it will be coming into the intersection like this. It will be crossing that location. Then it is going to take a turn like this. This is what is that 310 indicates. Understanding? I hope you are following it. Right or not? That's it. Now see, like that, if you are taking all the number of vehicles which are using that particular section, which all things will be getting, already we have discussed. If you are considering leg 1 first, see, entire leg we need to consider, okay? 150 is not there, 450 is there. So 450 plus 412. So both these things are there, no? From leg 1. Let me write separately for your better understanding. This is leg 1. Now from leg 2, all the things will come now. So 200 plus 1090 plus 310. So this is actually from leg 2. Just for your understanding, I'm writing like that. Now again, I need to add from leg 3. That 240, no, 240 is going to leg 4. It's not going to use that particular location, right? 240 will directly go like this. It's not going to use that. Now, what about this 1520? No, that is also not going to use, no? So it will be coming like this and it will be going like this, not going to use. What about 570? That also will not be using, no? 570 will be going like this only. That also not going to use. So no value from leg 3 we require. Right or not? The next is from leg 4. What about this 30? No, it's not going to use. What about 1080? No, that also not going to use because it will be coming like this, turning and taking the left turn like this. That also not going to use. What about this 600? Yes, 600 vehicles will be using that location because it's going to come like this, then it will be taking this turn. Understanding, guys? So that only that 600 will be coming. So from leg 3, nothing, right? Now 600, that value is actually for the leg 4. Okay, so all these values we need to add. That is nothing but our total traffic. Just add it. How much you are getting? Around 3062, right? Getting? That's it. Now this is our denominator part. Now numerator part we need to calculate. What is the numerator part? It's very simple. Listen carefully. What we need to calculate is P23. 23 means what? Vehicles are traveling from 2 to 3. So which is the starting location here? 2, 3. Vehicles are traveling in which direction? From 2 to 3 it is traveling, no? Always in the clockwise direction. There is no anti-clockwise movement here. Always clockwise. So starting point is 2, ending point is 3. Like that you just remember. Now how we are going to calculate that weaving traffic? It's very simple. To calculate the weaving traffic or that numerator, I hope you are able to read it properly. Actually, because of this surface, I'm unable to write in good handwriting. I hope you're able to follow it, right? So weaving traffic, how we are going to calculate it? Simply, the vehicles, the number of vehicles, okay? Vehicles from 2, okay, what we are going to calculate? Between 2 to 3, right? So this you need to consider. Now from 2, traveling from 2 to all other places, vehicles coming from leg 2, okay, better you can write leg 2. Vehicles coming from leg 2, better. Vehicles coming from leg 2 except V23. Understood? All vehicles coming from leg 2, which means what? This 200, 1090, 310. Or here I can write all vehicles coming from leg 2 means what? V21 will be there, V23 will be there, V24 will be there. Understanding? 2-1 in the sense from 2 to 1, from 2 to 3, from 2 to 4, right? So from this, what you need to eliminate? 2, 3 you need to eliminate. This you need to eliminate. Which means this is equal to V21 plus V24. This is not the end. Along with this, we need to add one more thing. All the vehicles going to which leg it will be? 2 to 3 we are considering, right? 2 to 3. So from the leg 2 to leg 3, right? That's it. So all the vehicles going to leg 3 except V23. That's it. Understanding? Understanding all the vehicles coming from this first leg. Okay, then all the vehicles going into this second leg. Second in the sense, whatever I have written here. Okay, 2 to 3. Now here also 2 to 3 we need to eliminate. Now, what are those vehicles? From 1 vehicles will be going into 3. From 2 vehicles will be going into 3. From 4 also vehicles will be going into 3. In this, what we need to eliminate? 2 to 3 we need to eliminate. So this will be V13 plus V43. Okay, so all these things we need to add. So just try to add it. Once you are adding all these things, what we are going to get? 2-1. How much is 2-1? Either we can take from the table or from the picture I have drawn. Okay, so 2-1 is 310. 310. Then 2-4. How much is 2-4? From 2 to 4. 1090, right? 1090. I'm just writing separately for your better understanding. Then 1-3. How much is 1-3? From 1 to 3, it is 450. Then 4-3. 4 to 3, it is 600, right? So 450 and 600 we need to add. So once we are adding all those, we are going to get 2450. That's it. Simple. Understanding? See, don't think that whenever they are giving you a data in the form of a table, we need to draw like this. No, not needed. Once you're solving a question like this, the next time when you're solving, easily you can do it without drawing the, what I can say, the picture and all. Or if you're drawing it, it will be easy for you. You're not going to make any mistake. That's what. So we got both the values, the weaving traffic and the total traffic. Now easily we can calculate what is the weaving ratio between the legs 2 and 3. That is going to be 2450 divided by 3062. That's going to be 0.8. Understood, guys? So I hope it is clear. If a 4-legged intersection is coming, we can easily do it like this. Now, if a 5-legged intersection, if they are giving, then what to do? The same thing, that's all. Only thing is one more direction will come, that's all. Okay, so you try to do that question as well, which is another previous engineering service exam question. I've already calculated it. Okay, you just try it and try to comment your answer in the comment box. Or should we solve this? I hope you can do it. See here, one thing you have to notice, 1 to 2, 1 to 3, 1 to 4, 1 to 5, like that they have solved, like that they have given, right? You cannot see any data here, V 2-1, 2-3, 2-4, 2-5 like that, right? They have not given that. Why they have not given? Because it is not needed, that's it. See, in the previous question also, see whether we have taken any data from this table. No, right? 2 to 3. I mean, from 3, whether we have taken any data from this 1520, 570, 240. No, right? So 2 to 3 we need to calculate. So the data corresponding to 3 vehicles coming from 3 we will not be using anywhere according to this trick. Understanding? So that is why they are not going to give. I mean, that's why they have not given the value, okay, I didn't tell you what to calculate, right? So ratio between 1 to 2, we need to calculate. So that the data for V21, V23, V24, V25, we are not going to use anywhere. That's the reason why they have not given here. Not needed. Understanding? So try to calculate it and try to answer, try to comment your answer in the comment box. I'll be telling you whether it is correct or not. Okay, let me just solve it otherwise, just to make your, what I can say, concept more clear. What I can do, if you're confident enough, just pause the video, then solve it and come back. Okay, otherwise, if you need more explanation, just be there. I'm going to explain that. Okay, first of all, you can just, to make sure that you are not going to make any mistake, you can just draw a figure here. Okay, something like this. This is one leg. This is another road, simply. Okay, one rough figure you can draw. That's it. Okay, so 5 legs are there, no? So it may not be symmetrical. Okay, always the road, the shape and all may not be symmetrical. Anything random. Okay, let me just call this as leg 1. This is leg 2, leg 3, leg 4, and 5. So those who have got enough confidence, just pause the video and solve it. Others, you can listen here. So between 1 and 2, we have to calculate, right? Now, what all things will be coming in the numerator? So P1, 2. Directly, I'm going to write it. Which all things will be coming? 1 to 2. See, what is there in the numerator? All the vehicles which are coming from 1, right, except 1 to 2, right? So 1 to 2 can we use? No. Which all things we need to add now? V1 to 3, V1 to 4, V1 to 5. That's it. Similarly, all the vehicles which are going to leg 2 except 1 to 2. What it will be? All the vehicles which are going to leg 2 means 1 to 2 we are eliminating. Then 2 to 2 will not be there. 3 to 2, 4 to 2, 5 to 2. Understanding? Understanding? So all these things will be coming in the numerator, right or not? That's it. Now, what all things will be coming in the denominator? Everything which are using that portion, which is this shaded portion. So what all vehicles will be using that? Whether 1 to 2 will be using? Of course, yes. So 1 to 2 is going to use it. Then 1 to 3, of course. 1 to 4, of course. 1 to 5, of course. Now, all the things from 1 is over. Now let me take leg 2. 2 to 3, no. 2 to 4, no. 2 to 5, no. 2 to 1, no. We don't need it. That's why it is not given in the table also. Understanding? Now 3 to 4, no. 3 to 5, no. 3 to 1, no. 3 to 2, yes. Why? The vehicles will be using this portion to exit to leg 2. Understanding? So 3 to 2 will be coming. I'm just writing 3 to, that's it. Okay. Now over. Leg 3 is over. Now leg 4. Leg 4 to 5, no. 4 to 1, no. 4 to 2, yes. 4 to 2 will be there. 4 to 3, yes. 4 to 3 also will be there. Understanding? Now let me take leg 5. 5 to 1, obviously not. 5 to 2, yes. Vehicles will be coming like this. Using this section, when crossing that section only, they are going to move to leg 2, right? So let me write here. So V52 will be there. Now 5-3, obviously there, 5-3. Now 5-4, yes, 5-4 is also there. That's it, now one already we have taken. Now just add all these values. Finally, you are going to get 1, 2, 3, 4, 5, 6. Let me just cross check. 1, 2, 3, 4, 5, 6. Yes, all the values in the numerator. Finally, you should be getting 727 on the numerator. Then in the denominator, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I hope I have not made any mistake. In case if I have made any mistake, I hope you might have already noticed that. Now 859 you are going to get in the numerator. All the values I'm not writing there. Okay. It will be 303, 64, 52, 122, 54, 132 in the numerator. 37, 303, 64, 52, 122, 54, 18, 132, 62, and 15 in the denominator. Just for cross-checking, I have mentioned that value. So finally, you should be getting 0.846. Hope you have got it. That's it. That's all about this weaving ratio. Now see, similarly, what practically we need to do? Right now, we have taken in between 1 to 2, right? Similarly, in between 2 to 3, we need to calculate all the procedure again. Between 3 to 4 also, between 3 to 5 also, between 5 to 1 also. So 5 different weaving ratios we are going to get in this particular roundabout. Whichever is maximum, that particular value is what we are going to substitute in our capacity equation. Got it, guys? That's it. That's all about this weaving ratio concept. Now, I hope you have enjoyed it. If you have enjoyed the video, please show your love in the form of likes and comments. Thank you so much. Take care.